Hey guys, how's it going? In this video we're going to look at how to create a basic stock price database using Pandas and SQLite. So first off we're going to have to say import Pandas as PD and import SQLite 3 as DB and also import yfinance as YF. And just a heads up, if you guys don't have these modules installed, you're going to have to say pip install Pandas, pip install SQLite 3 and pip install yfinance. If you don't have access to the pip command, you're going to also have to install that. So the companies we want to download, I'm going to store in a list called tickers. So the ticker symbols for these stocks, I want AMD, I want Nvidia, I want Tesla, so it's like that, Microsoft, and I want Google. There we go. So now to get our data, I'm going to say df equals yf.download. We want to download those tickers and I'm going to group them by ticker. Then print this out. So here we have our data. So as you can see, we have this multi-level columns. So we have an open, high, low, close and adjust close and volume for every ticker. But I actually want these stock names to become its own column, so we don't have this multi-index in the columns. So to do that, I'm simply going to use the stack function. So let's stack our data. I'm going to say df equals df.stack. We want to stack level 0. And I'm also going to reset the index so that our index columns become regular columns. And if we print that out, we're going to get this. So now we can see the date and level 1. Another thing I also want to do, I want to fix this date. So fix date. And I'm going to say df date is equal to pd.toDateTime inside df date. And then we're going to say .dt.string, I think it's called string from time, that's how we pronounce that. And we want the year, dash, then the month, dash, and then the day. And I forgot my equals. So if I run this now, we can see our data looks like this. Our date is now fixed and we have the stock names or the ticker symbols in its own column. Next up, I also want to rename this level 1 so it's actually the right thing. So I'm going to say df equals df.rename columns. This is going to take a dictionary. We want to rename level _1 to stock. There we go, and now it's going to look like this, rename to stock. Then I want to melt this data, so in order to save it in our database, we want to melt it down to a record format, where we don't have all these columns, we have it as one column called item, and the value of these cells are going to go into the value column. You will see what it looks like just now. So I'm going to say melt our data and create a new data frame melt df, and I'll set that equal to df.melt. Our ID vars are going to be, currently it's the date and the stock. This is kind of like our index at the moment. For every combination of date and stock, there can only be one entry, if that makes sense. Our variable names are going to be item, sorry, it's variable name, and then our value name is going to be value. Then I'm also going to drop the NA, so melt df equals melt df.drop NA. And now our data looks like this. So it's melted down into kind of like a record or database format. Great, so now we can actually make our database connection. So I'm going to say con equals db.connect. And in this connect, we're going to give a file name or a path name. I'm going to call mine pandas.db. And then to interact with this database, we're going to need a cursor. So our cursor is simply going to be con.cursor. So first off, we're going to need to create our tables. So I'm going to say cursor.execute. And this is going to take our SQL query. Inside, I'm going to say create table if not exists stock data. And we are going to have a date column, simply going to be text format. We're going to have a stock column, also text. We're going to have an item, also text, and then the value is going to be real. Also on this table, we want to create a unique index, so we don't have multiple or duplicate entries for the same date, stock, and item. These have to be unique. So I'm going to say create unique index if not exists. I'm going to call it ix_stock data on stock data, and our index is going to consist of the date, the stock, and the item. Now, let's turn this melted data frame into a table in our database. So we're actually going to do something a little different here. I'm going to say melt df.to_SQL. First off, we're going to give the name of the column. Now this is where things are going to be a little different. I'm going to say temporary table, and then con is going to equal con. If exists, we want to replace, and index I'm just going to set to true, but it's not really going to be needed for this tutorial. So we just created the stock data table, but we are writing to a temporary table. Why is that? Well, pd.sql is quite limited. So for if exists, you basically have two options. You can either say replace, so it's going to replace the entire table, or you can say append. Now imagine we are working with a data frame and some of the data in your data frame already exists in the database. If exists will either replace the whole table or attempt to add every record in your data frame when you say append. This is not what we are looking for. We don't want to replace the whole table, and if the data already exists, it is not efficient to add it again. It could also give us unique constraint errors. So by using this approach, you're going to see now, we are able to make use of insert or ignore or other common SQL functionalities. So what we're going to do, we're going to put our data frame in a temporary table and then write the entries from there to our actual table. However, keep in mind, when you add your data for the first time, you could also write it directly to the actual table. In that case, I would say if exists equals append. So now the data frame is in the temporary table. Let's move it to the actual table so we can update our actual table. To do that, we're going to say cursor.execute. And in here, we're going to just give it a basic SQL query. So insert or ignore into stock data. And we want to do the date, stock, item, and value. From where are we getting this data? We're going to say select date, stock, item, value from temporary underscore table. And then once we're done with that, we're going to say con.commit to commit our changes. Let's run this. So I forgot to close the parentheses here. Let's run this again. So now I'm browsing this database, and you can see we have this temporary table in the database. We also have the stock data, and it inserted exactly the way we wanted. So let's go ahead and read from our database, make some changes, and then write it back to the database again. So I'm going to create a new data frame called just db2 equals pd.read underscore read. Now it's going to be read SQL, and then our SQL query is going to be select all from stock data, and then we simply give the connection as our second parameter. If we print this out, it's going to look like this, but we actually want to pivot this data so that we have these items as their own columns. So that's going to be db2 equals db2.pivot. Our index is going to be stock and date. Our columns is in the item column, and our values are in the value column. Then I'm also going to reset our index to have our index as normal columns. And once again, I did not close my parentheses. There we go. Sorry, I messed that one up quite badly. And now our data frame looks like this. Let's add another column to it. So I'm going to say ma20 equals db2.groupby. Now this line is actually going to be fairly complicated because I'm going to use group by to do the moving average. So that's because we have multiple stocks here and they all need to have their own independent moving averages. But don't worry about this line too much. It's merely just to illustrate how we will add a new column and then write it to our database. So group by, we're going to group it by stock. We're going to use the adjusted close column. And I'm going to transform it to say lambda x, and we're going to say extra rolling. Let's do 20-day moving average. Instead of having not the numbers, I'm just going to add another argument 1 there. So a minimum of 1 is still going to be fine. Don't worry too much about that. And then let's print this and see what it looks like. So we've now added a 20-day moving average to our data frame. And you can see here, instead of giving us not the numbers for the first 19 entries, it just used what it had. That is what this one parameter does. So let's now melt this data and add it to our data frame. So melt, and db2 is going to be db2.melt id vars. Those are going to be our date and the stock. Our variable name will be in the item column. Hello?
Hello. Do you want to come to the beach with us later?
And our value name will be equal to value. And then I'm just going to make sure we don't have any not and numbers by dropping them. Then we're going to write this to SQL by saying db2.to_SQL. Name of the table, once again our temporary table. Con equals con. If exists, it's going to be replace. And our index, once again true. Then cursor.execute to actually move this from temporary table to the actual table. Insert or ignore into stock data, date, stock, item, value, select date, stock, item, value from temporary underscore table. Then just con.commit. And it's just good housekeeping to also say con.close to close our connection. So I really hope you guys enjoyed this video and found it helpful. If you did, please leave a like down below and consider subscribing, and I'll see you in the next one. Goodbye.